Alright, next we're going to talk about graphing inequalities in section 2.6. We look at number 1, we have y is less than or equal to 3x plus 7. What we're going to do is we're going to start off by graphing it the same way we would graph a line. So we're going to start with our y-intercept at 0, 7. We plot our y-intercept, and we have a slope of 3. So if I were to change that into a fraction, it would be 3 over 1. So we're going to rise up 3, and we're going to run right 1. So we go up 1, 2, 3, right 1. Or we could go down 1, 2, 3, left 1, down 1, 2, 3, left 1. You gotta keep going, gotta cover that whole piece. So down 1, 2, 3, left 1, down 1, 2, 3, left 1, 3, 1. Alright, so now we have all of our points in place. We think about the symbol we have. If it's less than or equal to that. So if I want to be less than or equal to that, I'm going to include that line. So I'm going to have a solid line showing that it can be equal to that line. Now I have to think about if it's less than or equal to that. I'm going to include a whole portion of my graph. I have to ask myself, am I going to include everything over here or everything over here? Because just like when we have our simple inequalities, we normally would say, okay, if it's less than or equal to 3, I would have 3 closed line or a closed circle to the left. So it's more than just one number. So our graph is going to be more than just our line. We have to figure out which part of our graph is it going to be, to the left or to the right. Some of you guys can think, okay, less than or equal to, I know for sure that that's going to be the red portion over here. Some of you may not be able to see that as easily. So what I suggest you do is choose a test point. Choose an obvious test point. And I normally like to choose 0, 0 if it's an obvious in one direction or the other. So I wouldn't choose something like right here, even though I know that it's going to be part of the right hand side. Don't choose something unless you know it's for sure part of the left or part of the right hand side. And again, I normally choose 0, 0 just because it makes your numbers nicer. So if I have 0, 0 and I plug that into my equation, I have 0 is less than or equal to 3 times 0 plus 7. That's 0 plus 7. Is 0 less than or equal to 7? Well, yes, that is true. 0 is less than 7. Since that was true, that is the portion that I'm going to shade. So the graph of this is going to be our line with a solid line, and it's going to be everything below it's going to be shaded. When we look at number 2, there's 2 ways you can approach this. One of the ways that we know how to graph a linear equation that's in standard form is to use our intercepts. So I've got 3x equals 30, so x is equal to 10. So I know I'm going to have the point 10, 0 on my graph. 5y equals 30. I know y is going to be equal to 6, therefore 0, 6 is going to be on my graph. So I'm going to graph this line using my x and y intercepts. Now it has to be greater than 30. It doesn't say that it has to be equal to. So it's not going to be equal to our line. To indicate that our line is not included, we used a dashed line. Before, when we talked about inequalities, we used a closed circle if it was included and an open circle if it wasn't included. For graphing our lines, it's a solid line if it's included, and it's a dashed line if it's not included. Alright, so now again, if it's going to be greater than 30, you have to think to yourself, well, is everything down here greater than, or is everything up here? Some of you probably are saying, well, greater than, that's going to be above my line. I know anything greater than or equal to or greater is above. Again, some of you are not going to be able to see it, which is totally fine. Use your test point. 0, 0 is obviously going to be below. So when I plug in our 0, 0, we've got 3 times 0 plus 5 times 0 is greater than 30. So I've got 0 is greater than 30. 0 is not greater than 30, so that's not true. That means that is not part of the solution, and hence we were correct that we were going to shade everything above the line. You also could have, if you're not comfortable with graphing the intercepts, which is fine, all you had to do was put it into slope-intercept form. So we're going to move that 3x over, 5y is greater than a negative 3x plus 30, divide by 5, and we've got y is greater than a negative 3/5 x plus 6. So we would have started at 6 and gone down 1, 2, 3, right, 1, 2, 3, 4, 5. And we were pretty accurate there. Down 3, right 5. Up 1, 2, 3, left 1, 2, 3, 4, 5. And you can see that the line we made with our intercepts is relatively close. Again, this is why I wouldn't necessarily choose that point as your test point, because we don't know, is it on the line, is it off the line, is it above the line, is it below the line? So use a point that is obviously in one direction or the other. So to recap what we just talked about, if you have a less than or a greater than sign, that means that our boundary line is not included. So we're going to use a dashed boundary line. If you have a less than or equal to or a greater than or equal to, you are going to use a solid boundary line. That's going to show that that boundary line is going to be part of your solution. And as we said before, not sure which way to shade, you're not really sure which way is greater than, which one's less than, use that test point, and that test point cannot be on your boundary line. Never use a test point on the actual line itself. Alright, these are our last two graphs. We've got y is greater than or equal to a negative 4. Hopefully you are a little lights going off. Y is greater than negative 4. That's not anything like the lines that we just did. Y equals is a horizontal line. So when we go, we've got y equals a negative 4. We're going to draw a horizontal line at negative 4. Because it's greater than or equal to, it's a solid line. And since it's greater than or equal to, it's going to be everything above the line. If you can't see which way to shade, use your test point. Next we've got x is less than 7. Well, x equals is a vertical line. So we know that we're going to have a vertical line at 7. So we go to x is 7. Since it's less than, we're going to have a dashed line at 7. And it's less than. If it's going to be less than, then we are going to shade everything to the left of the line. So greater than is right, less than is left, or greater than is up, and less than is down. If you don't see that, take the extra seconds to plug in 0, 0 and test a point. If that point satisfies it, then that's the direction you shade. If that point does not satisfy it, shade the other direction. Take those extra couple seconds to make sure that you have it correct if you don't see it. Alright, and that's it for today. Nice, short, and sweet.